A very warm welcome to this FEDERATE webinar with the title RISC-V-based SDV Hardware Platform for the European-driven Software-Defined Vehicle Initiative and the role of the Rigoletto project. This interview is part of a FEDERATE webinar series. FEDERATE is a coordination and support action funded by the European Commission. Visit us at federate-sdv.eu. My name is Peter Briller. I work for EWL as Principal Technology Scout, and it's my honor to introduce Knut Huffeld, who will be interviewed by Michael Paulweber. Let me start with Knut. Knut is Vice President of Research and Development at Infineon Technologies based in Neubiberg in Germany. He holds a diploma in Electrical Engineering and Informatics from the Technical University of Ilmenau and has been with Infineon, formerly Siemens Semiconductor, since 1995. With over 2 decades of experience in semiconductor research and development, Knut has led numerous European and national research initiatives. He has played a key role in major projects like EMC Squared and Productive 4.0 and has been actively involved in ENIAC, Artemis and Excel programs. He also represents Infineon in strategic platforms and contributes to European Commission working groups on digital industry. Knut's current focus includes embedded real-time processors, SDV architectures, and RISC-V-based platforms, with involvement in projects like Rigoletto, where we will hear about today. As a long-standing member of the Inside Steering Board, he is committed to advancing collaborative innovations across systems, applications, tools, and software development. Now let me introduce Michael, who will be interviewing Knut in today's session. Michael Paulweber serves as Executive Advisor for Software-Defined Vehicles and Advanced Driver Assistance Systems and Automated Driving at EWL's headquarters in Graz, Austria. He holds a PhD in Control Theory from Graz University of Technology and an Executive MBA from St. Mary's College in California. With over 40 years of experience in the automotive industry, Michael plays a key role in shaping the future of mobility. He currently serves as Vice President of the European Industry Association Inside, as a Vice Chairman of ESPS Austria. He is member of the steering board of the European Chips Joint Undertaking, and he is also coordinator of the FEDERATE project. In addition, Michael also lectures at Graz University of Technology and the University of Applied Sciences. Okay, gentlemen, thank you very much for joining us in today's FEDERATE webinar with the title RISC-V-based SDV Hardware Platform for the European-driven SDV Initiative and the role of the Rigoletto project. We're looking forward to a very interesting discussion. The stage is yours.
Good afternoon. I'm really excited to have this interview with Knut about one of the most exciting topics in the automotive industry, software-defined vehicle. Knut, why is RISC-V all of a sudden attractive for automotive and semiconductor industries? Can you give us a short background?
Yeah, we discussed it with the background on Rigoletto, the latest RISC-V research project on European level dealing with RISC-V. RISC-V is, so to say, a once-in-a-lifetime opportunity to set up fantastic and performant embedded processors involving all the partners you can think of, from university and institutes to industrial partners, with the full freedom of an open source approach to design and implement suitable devices needed, for example, by the automotive industry. And Rigoletto, the acronym stands for High Performance Automotive Processors and Computing Platforms. And the overarching goal is to, let's say, enable the RISC-V instruction set and technology to be deployed in a real-time and embedded application domain like automotive.
The European Commission started several projects in these initiatives to create a European-driven RISC-V ecosystems and an offering for an automotive software-defined vehicle hardware platform. The current already started projects and the proposals in evaluation account for an investment of more than 450 million euros spent from the European Commission, the participating states, and to a large extent also from the industry. Knut, can you give us an overview what is going on in these projects with one of the focus projects, Rigoletto? And do you have a roadmap for it?
Yes, the slide in the background should indicate that we are working since a couple of years on European level with the focus on embedded application domains, especially automotive, not to mention the RISC-V initiatives on high performance computing, not shown here. Here you see more the dealing with embedded application domains, starting with the Tristan project, which will be finished this year. Then we have the running Isolde project, followed up in the Rigoletto project, started in July this year. And this is a perfect initiative for us to have certain continuity to follow up the topic. And if you would have a closer look into the consortia, you will easily recognize that a couple of core partners continuously follow up in this project, accomplished by technology and software experts, by universities. And so this is really a great opportunity to follow up a topic from the lower TRL in RIA projects until the higher TRLs in an innovation action, and from functional experiments up to prototypes close to industrialization. And the latest approaches under the coordination of NXP. This year, we filed the project proposal Turandot, an innovation action which is at the moment under evaluation in the CHIPS-GU. And if we will succeed, this can complete the circle until close to product realization in this RISC-V area. And not to forget, this hardware development is not driven isolated. So we see this already in a good agreement and co-design with the initiative for software-defined vehicles. And the basic idea is that the new processor devices and compute devices should allow to implement compute platforms for cars able to perform and host the upcoming new software stacks researched and developed in the SDV initiatives. And FEDERATE is there a good communication platform to align and synchronize between these two initiatives. And we appreciate this setup very much.
Thanks for explaining this really large collection of projects working towards one goal. Which results do you expect from these projects in the area of the hardware platform for software-defined vehicles? When will we see prototypes? When will SOP-ready chips based on RISC-V available for the automotive industry, especially for automotive central compute systems?
We think on a iterative implementation. So if you have a closer look on Rigoletto, where we work in 4 work streams indicating the different performance levels of embedded processors. So on one hand, the control processors, then we follow up the high performance processors, more application oriented or based, accomplished by AI and machine learning accelerators, which all should be the basis for the upcoming automotive computing platforms. In Rigoletto, we will focus on the functional realizations and prototypes, and on the enablement of RISC-V for real-time and embedded as such, and with a focus on 32-bit compute elements. And we expect to see first results in 2027, 2028, fully functional, maybe not fully operational in terms of environmental aspects, but functional prototypes will be in the focus of the Rigoletto project, and in the follow-up project, in the Turandot project, the goal is to reach TRL level 8, which means that the test devices developed there will be also full operational in the application environment and fulfill the environmental requirements as well. So let's say in 2-3 years from now, we will see related products in the market.
Thanks for these insights in this really marvelous initiative. I would like to move to a little more generic topic now. This week, again, we heard news from a potential chip shortage in the automotive industry, which will slow or may slow down production in several automotive plants. In this case, Europe is hurt by the difficult global geopolitical situation. Can you give us a short insight about the challenges in which the global semiconductor industry value chains are facing, and why it may lead to chip shortages in various European industries? Which kind of activities you think we should have in Europe to make us more independent of these threats, which currently obviously all the time available?
Yes, of course, this is indeed a challenge to cope with political and geopolitical effects these days. All semiconductor or large semiconductor companies are acting globally, and therefore, of course, we have different manufacturing sites, different design locations around the globe. Nevertheless, we are see that we have to establish a good and almost sustainable infrastructure within Europe to be able to act relatively independent from such aspects. And one aspect is on one side for power electronics, for Infineon, for example, we have our own manufacturing sites and we have the control over that. This is, let's say, more on the safe side. We have other aspects like for logic ICs, for microcontrollers and processors. We use, like other semiconductor suppliers too, the manufacturing capabilities from Global Foundries or TSMC, for example, and it's no secret this is settled in Taiwan and China, and not forget the packaging capabilities, and we try to do our best to establish even these parts of the value chain within Europe. To mention an example is we are supporting the setup of an TSMC manufacturing site in Dresden. We strengthen the design capabilities for logic ICs in Europe. And we are convinced or sure that this is a big advantage for Europe, that we still have the sovereignty to design chips according the need our European customers, and we are really serious active to sustain the ecosystem within Europe.
Thanks, Knut. That's a really encouraging information. Let me summarize what I understood so far. We are working on a European software-defined vehicle platform consisting of two parts: a hardware platform, which you described in more detail, and a software platform. Typically, these hardware and software platforms are used in new central zonal E architectures. You explained that you're working on two different kinds of control units on CPUs or processors, one for control tasks, for which are necessary for the various controllers for mechatronic components as batteries, e-motors, suspension systems, window openers, seat adjustment, and many more. And they all need specialized real-time microcontrollers. On the other hand, we have new customer visible software-defined vehicle applications, which need central compute platforms with very much power, compute power and AI power, will be based on RISC-V and with its AI accelerators, as you explained before, with close, secure, and reliable connections to cloud services. Examples for these SDV applications are currently in the news very often: automated driving, advanced infotainment software, software on demand, regular over-the-air updates of the software to keep the vehicle functionality state of the art, and many other applications which eases the life of customers. There's automatic tolling, automatic parking, and so on. In the software side, the activities activities in the hardware platform are supported by activities on a software platform, which works on a middleware, on which then differentiating applications will be built. One of the new requirements or the new challenges is that a lot of the functionality of these new applications are split between functionality in the vehicle and in functionality in the cloud. For example, if you think about automatic tolling, you have to know which kind of tolling company is in charge and how to pay and all that. So we have now two platforms. We have the hardware platform and the software platform. Which kind of interfaces do you see between these two platforms? How they are managed and which kind of, let's say, challenges are still remaining?
Yes, yes, indeed. Maybe we should bear in mind that we have not that software or that software stack and that hardware in a car. It's pretty heterogeneous, and you will find a variety of different hardware and processors and different software running in a car. And probably we can, on one hand, maybe distinguish a bit or separate a bit in classical control functions and to steer and control the driving functionality of the car. Then we have the field of environment recognition to make highly automated driving possible. We have to host new kind of software services, and this therefore we have to provide different hardware. And on one side, the let's say, the implementation of hardware and software might be very close and should be performed in a close hardware-software co-design. If you look on the driving functionality on the classical functions, where we will, of course, provide as far as possible the hardware-related software also from our side and improve our resources there. And then you have the area where there are more compute platforms and central platforms are required with very performant application compute power to host any service and any project or software you can think of, and where the target is to provide a compute platform which is capable to host whatever is required from the application side, and where we will of course not be the single source. And for this new kind of hardware platforms, we see that we have to host software which is independently developed from our hardware, and we have to take care on all means, even on the lower software levels, to make this possible. So I think that any software layer which directly interferes with the hardware will come from Infineon and our close suppliers in future, and will also be maintained in this part of the value chain to give the implementation of application software the freedom to implement these new functionality relatively independent from concrete hardware. And this might be new in the automotive context. And in terms of RISC-V, of course, we will step by step come up with more and more performant devices. And it is also part of a responsible market strategy to enter the market with reliable devices and step by step offer more performant and reliable compute platforms which are trustable and highly reliable as expected from the automotive sector.
Thanks for this interesting news. I would like to have another aspect to get a better understanding what's going on in Rigoletto, Turandot, and Tristan, Isolde. We spoke a lot about the RISC-V hardware and all the accelerators and so on, but I think these projects are not only working on hardware devices, but also providing specific parts of the software. If you look from a software point of view to software-defined vehicles, then we need compilers, optimizers, debuggers, which are especially adapted to this new RISC-V adapters. Next, we need virtualization software fitting to either these low-level microcontrollers or these high-performance compute platforms, together with operating systems, which are adapted via board support packages, drivers to abstract the hardware from the software. Above the more classical software, we have this software platform, the middleware, which abstracts the functionality for the applications, and finally we have the applications. In addition, these over-the-air updates and also this very rapid involvement of the hardware require continuous updates, which needs then a very automated development. platform for partially hardware and a lot for the software. So which kinds or which parts of this large variety of software are also worked on in these RISC-V projects, flower bucket, which you described before, Rigoletto, Turandot, Restan is all the supporting the existence or the creation of these software-defined vehicles.
Yes, of course, we have resources deployed on software issues in Rigoletto and also in Turandot, and moreover on the design infrastructure for implementing software, toolchain aspects, and so on. But with this, as these projects have a clear focus on hardware, this is pretty limited. And so we widely try to rely on an exchange with the SDV projects to get an good insight, which we have to prepare from hardware side and from the lower software levels, from the hardware abstraction, to be ready and meet the future needs of and requirements from SDV initiatives, from this upcoming software stacks. So yes, software is important, no doubt, but we cannot and we do not try to make here a parallel resource stream. Here we rely widely on the communication and exchange with the SDV initiative.
Yeah, thanks for this explanation. I guess it's important that we have a really close collaboration between, I would say, three initiatives. We have this RISC-V hardware platform initiative. We have the software platform initiative, which is partially supported by this public funded project, as you have shown, Shift to SDV, Half for SDV. And we have a large community, a large number of projects in the open source area. And here Eclipse SDV plays a major role in that to speed up the development of the software platform and to ensure the success of these initiatives. Which kind of, and FEDERATE is trying to do a lot to create this collaboration, to help to get a common understanding, to exchange information. The European Commission is now starting this European Connected and Autonomous Vehicle Alliance, which again will work on this collaboration. What do you think? What is needed in addition to all these activities, trying to bring all the communities together and to work towards this common goal of a European-driven but globally used software-defined vehicle platform?
Yeah, we didn't touch the third initiative already in place, dealing with heterogeneous integration and chiplet approaches. If it comes to implementation, you need a suitable implementation technology to set up all the future nice and performant compute platforms. And we have a high expectation that this can solve issues not only from performance and power consumption aspect, but also from the cost figures to come along with affordable solutions for our future vehicles. And even from the chiplet approach, we are faced requirements respected by the hardware devices. And if this is maybe another aspect, all these devices getting so complex that chiplet is maybe a new solution to combine different functionality which cannot be provided by one supplier, or even more, if we implement new microcontroller and embedded processor devices, not a single company is capable to develop everything from scratch. We can benefit a lot from a good infrastructure, from a good ecosystem of specialists providing dedicated hardware IP, and this is also a path we strongly focus on. We set it up the Quintaurus company, taking care to involve the ecosystem of RISC-V in Europe. Stakeholders are, for example, NXP, ST, Bosch, Infineon, and others. And this should enable affordable solutions for upcoming new processor devices as well.
Knut, thanks for these in-depth insights in these software-defined vehicle initiatives on the hardware side as well as on the software side. We came to the end of this webinar. I'm looking forward for a long time of very interesting collaborations, and maybe we'll have another webinar in a year from now to see which kind of tangible outcomes we already can see. So thanks for the interview and have a good afternoon.
Thank you very much. Take care.